and welcome to this lesson. We want to look at the question given to us on partial pressure. The quiz given, we are going to solve the quiz together in this lesson. This is the quiz, and in question number 1 we have that 150 cm³ of methane gas collected over water at 20 degrees Celsius has a pressure of 570 mm mercury. Assuming that the saturated vapor pressure of water at 20 degrees Celsius is 42 mm mercury, calculate the pressure of dry methane gas. Now the question is saying this, that we collected a methane gas over water, and like I explained in the main class, that whenever you collect a gas over water, the pressure of the gas will be mixed with the pressure of water vapor, that is gaseous water. Water evaporates, it turns to vapor and escape. So anything you are collecting over water, you are collecting it along with the vapor of water. So for you to get the pressure of the gas alone, you have to subtract the pressure of the water gas present there or at that temperature. So we are given the saturated vapor pressure, which is the pressure of the water, and we are given the total pressure of the gas. The total pressure is the 570 mm mercury given to us. So what we do now is to subtract the pressure of the water from the total pressure given to us. Now we have that of the gas, of the dry gas alone remaining. So that is the simple thing we do here. This is very, very simple. Partial pressure is very, very simple. Now we go there. Let's solve it. Now solution number 1. Question number 1. To solve it, now we are given the total pressure. Let's call it PT. It is equal to 570 mm mercury in the question. And we are given SVP, saturated vapor pressure of water, as 42 mm mercury. 42 mm mercury. The temperature 20 degrees Celsius given to us there is just showing us the temperature at which the gas was collected. It is not used in the calculation, or else the temperature is not the same. If the temperature is not the same, then that means that the pressure is not at the same condition. You must make sure that the pressure were measured under the same condition. That is why we are given the temperature at which both gases were collected. If the temperature are not the same, you have to use the appropriate gas law to get the equivalent pressure for that particular temperature. Now SVP is equal to 42 mm mercury as given in the question. Now we are looking for the pressure of the methane gas. Let's call it PM. Now this PM, we have that total pressure is equal to PA plus PB, the general formula. Now in this case, our PA is equal to PM, pressure of the methane gas, then plus PB is the saturated vapor pressure, we have SVP. So we have our total pressure as 570, and this is equal to PM, we are looking for it, plus saturated vapor pressure is 42. So we have that our PM is equal to 570 minus 42, and this gives us 528 millimeter mercury. So this is the answer to number 1, 528 millimeter mercury. Now let's look at question number 2. In question number 2, we have that 3 gases measuring 0.4 mole, 0.2 mole, and 0.8 mole respectively were mixed. If the combined pressure of the gases is 1078 Newton per meter squared, calculate the partial pressure of each of the gases. Now we are given the number of moles of each of these gases, and we are given the total pressure as 1078 Newton per meter squared. Now in the second formula given in the main lesson, I said that number 2, I said that for you to get the partial pressure of any gas when the number of mole of it is given, the partial pressure, let's call it PT, PA, maybe we are looking for the gas A, partial pressure of any gas, let's call it PA, is equal to the mole fraction. Mole fraction means the ratio of the mole of the gas to the total moles in the mixture. Now let's say the number of mole of gas A is equal to Na over the total number of mole is Nt, then times by the total pressure given. Na is the number of mole of gas A, Nt is equal to the total number of moles, and Pt is equal to the total pressure given. Now we don't know our PA, that is for the first gas. In this case, we are given 3 gases, not numbered, not named, but we are giving it, we are assigning A to them. To the first one, PA is equal to Na. Na is equal to number of mole of gas A, which is equal to 0.2. Nt, we don't know our Nt. Our Nt is the total number of moles, which means that we have to add all the moles given to us to get Nt. So we have 0.2, which is the first gas, plus 0.4 for the second gas, plus 0.8 the third gas. So everything is going to give us 1.4. Everything is going to give us 1.4. First gas, 0.4. Okay, we have 0.4, 0.2, and 0.8. The first one is 0.4 plus 0.2 and then 0.8. It will still give us 1.4. This is the total number of mole Nt. Now, this one is the number of mole for Na. It means that Na is equal to 0.4, Nb is equal to 0.2, and Nc, let's call the other gases B and C, is equal to 0.8. Now we know our total pressure. Our Pt giving to us PT. PT is equal to 1078. Think so. PT is equal to 1078. So we have this. Now to get for gas A, for the first gas, PA is now equal to the number of mole of gas A over the total number of moles. The number of moles for gas A is 0.4. Total number of moles is 1.4 multiplied by 1078. This gives us 308 millimeter mercury. This is the answer to number 1, 308 millimeter mercury. We simply divide the number of mole of gas A by the total number of moles and multiply by the total pressure. So we have this for gas A. We are getting the partial pressure for the 3 gases involved in this mixture. Now for gas B, which we can now call PB, it is equal to number of mole of gas B over total number of mole times total pressure, which is equal to number of mole of gas B is 0.2 over 1.4 multiplied by 1078. This will give us 154 millimeter mercury. So this is the answer for gas B. The partial pressure of gas B is 154 millimeter mercury. Now for gas C, PC is equal to NC over the total number of moles multiplied by PT, total pressure, which is equal to NC is 0.8 over the total number of moles is 1.4, then multiplied by total pressure is 1078, and this gives us 616 millimeter mercury. So this is the answer to number 2, PC, that is partial pressure of gas C. So we've gotten the partial pressure of each of the gases involved in question number 2. Now question number 3. Question number 3. In question number 3, we have 32 grams of gas A and 64 grams of gas B were mixed. If both exert a total pressure of 2.2 times by 10 raised to power 4, this should be millimeter mercury as a unit, at a constant temperature, calculate the partial pressure of gas A and gas B. Now let's look at the question again. We are given the masses of gas A and gas B as 32 grams and 64 grams, and then we are given the total pressure as 2.2 times by 10 raised to power 4. Here we are not given the number of moles directly, but we need the number of moles to solve. Now, molar mass of gas A is equal to 93 grams, and molar mass of gas B is equal to 42 grams. Now we can use the molar mass and the mass given to us to get the number of moles for each of the gases. Now let's go there. number of mole for us to get partial pressure of gas A, it is equal to partial pressure of gas A is equal to number of mole of gas A over total number of moles multiplied by the total pressure PT. Now, our number of mole for gas A, Na, number of mole is mass over molar mass of any substance. So for gas A, we are given the mass as 32 and the molar mass of gas A is 93. So we say 32 divided by 93, that will give us 0.3441. 0.3441. This is the number of mole of gas A. The number of mole is not given directly. We have to use the number of mole and the mass of the gas given to. You have to use the molar mass and the mass of the gas given to us to find the number of moles. So we've gotten Na. Now Nb, we also have to get Nb in order to get total number of moles. So Nb is equal to number of mole of gas B plus number of mole of gas B, which is equal to Nb is equal to number of mole of gas B, which is equal to mass of gas B over molar mass of gas B. So we have 64, which is the mass of the gas B given to us in the equation, over molar mass of gas B is 42. Now 64 over 42 gives us 1.524. Now we have Na and Nb. We have the different number of moles. Now we can combine two of them to get the total number of moles. So total number of moles Nt is now equal to the first number of moles, which is equal to 0.3441 plus 1.524. Now this gives us 1.8681. So the total number of moles is 1.8681. Now we can now look for Pa. Partial pressure of gas A is now equal to number of mole of gas A over total number of mole multiplied by total pressure, which is equal to Na. The mole ratio of gas A is equal to number of mole of gas A, which is equal to 0.3441 over the total number of moles now is 1.8681, then multiply by 2.2 times by 10 raised to power 4. If we multiply this, we are going to get that our Pa is equal to 4.315 millimeter mercury. So this is the answer to question number 3, and I hope that everything here is very clear. Thank you.